Welcome to another segment of my mathematics O level, videos as we try to conclude now on calculus. As I look at my last, examples that we are going to have. So I'm interested in this question and also that question, just to help you see how you can go about answering that. So these questions did come in the Examination Council of Zambia past paper. So these are some of the sample questions that I'm trying to answer, so you can do well to simply practice. So one, it says the equation of a curve is that find the equation of the normal. So remember finding the equation of the normal where x is what? Where x is 2. So they want us to do that. So number one, A, they've given us y is equal to x to the power 3 minus 3 over 2, then x raised, x raised to the power 2. But remember they are telling you when x is at the point where x is equal to 2, that's for the A part. So we can know, first of all, what is the value of y. That's what I told you. It's a good custom to know, first of all, if they have only given you 1 point, get to know the value of y, especially when you're finding the equation of the normal. Very important. So therefore, we are going to find y. Let me just find y. So replacing x, so it will be 2 raised to the power 3 minus 3 over 2, then 2 raised to the power 2. 2 raised to the power 3 will give us 8 minus 3 over 2. 2 raised to the power 2 is a 4. 2 there, 1, 2 there is a 2. 2 times that will give you a 6. So therefore y will be y is going to be a 2. So when x is a 2, y will also give you a 2. So very important that you get to know that. Now since we know that, we know what our value of y is, let's proceed and work out our calculation. So it says the equation of the normal. So as usual, we need to find the gradient of the tangent first, then we can know the gradient of the normal. That will help us to find the equation once we know the equation of the normal. So let's find dy over dx. So that is going to be 3x squared, and when you differentiate that, it is 3 over 2, but that is going to multiply by 2. Remember, this is over 1, 2 and 2 cancel, so I'll remain with 3. So therefore it will be 3x. That one reduces by 1. Now remember, we need to find the gradient dy over dx when our x, what's the value of x? They told us at x is equal to 2. So we want to know what is the gradient at this point when x is equal to 2. So it will be 3 multiplied by 2 raised to the power 2 minus 3 times 2. So that will be 2 raised to the power 2 is a 4 times 2. That's a 12 minus, that's a 6. So that will give us the gradient is 6. So this gradient that we have actually gotten is the gradient of this gradient that we have gotten is the gradient of the tangent. The first gradient you get is always for the tangent is 6. So how do I know the gradient of the normal? It's negative 1 divided by the gradient of the tangent. So negative 1 over 6. So it will be negative 1 over 6. Now, once we have the gradient of the normal, so we are going to use the gradient of the normal, negative 1 over 6. And the point when x is 2, y was giving us 2, so that we can find the equation. But first of all, you need to know the y-intercept. So how do I know my y-intercept there? Well, my y-intercept will replace, remember that is x, that is y. So it will be 2 is equal to gradient negative 1 over 6 times x, which is also a 2, plus c. 2 there, 1, 2 there, 3. So it will be 2 is equal to negative 1 over 3 plus c. When this goes the other side, it will become a positive 1 over 3 is equal to c. So in this case, 2 plus 1 over 3, that is going to give us a 7 over 3 is equal to c. So our y-intercept is that. So if our y-intercept is that, I can now find the equation of the normal. I can therefore say, equation of normal, the equation of the normal will be y is equal to, remember our gradient was negative 1 over 6x plus 7 over 3 as a y-intercept. So that is the equation of the normal. So this is what they wanted you to do. All right, let's move on to the B part there. So the B part there, Number 1b says the coordinates of the stationary points. Now the coordinates of the stationary points, we have already found the gradient dy over dx. We have already found that it was 3x squared minus 3x. That was the dy over dx. Now when they tell you at the stationary points, you need to remember at the stationary points, when they tell you at stationary points, dy over dx is always equal to 0. So in other words, they are telling you when dy over dx is equal to 0. So I'm just going to say 3x squared minus 3x. I'll equate this to 0 because at the stationary point, dy over dx is always 0. Now, stationary point, you can think of it if you have a curve like this, you have a curve like that, at the turning points, those are the stationary points. Dy over dx is 0 at the stationary points. Dy over dx is equal to 0. So whether you have that, those are what we call stationary points. Dy over dx is always 0. That is what you need to remember. So equate the gradient to 0 because at the stationary point, the gradient is always 0. We can divide through by 3 so that we reduce the expression there. So that is going to give me x squared minus x is equal to 0. What is common there? Well, x is actually common. And when I divide x there, I'll remain with x there, I'll remain with 1 is equal to 0. So we equate each to 0. So x is equal to this x will be equal to 0, or x minus 1 is equal to 0. That's what we mean. So therefore, x is equal to 1. So now, it simply means that you have 2 points. X can be 0 or x is 1. So we need to find the corresponding values of y because the question says we find the coordinates. So how do we do that? Okay, so you are going to get, you are going to replace these values into the original expression. So I'm going to say when x is equal to 0, what is the value of y? So we'll replace it in there. So it is going to be y is equal to x raised to the power 3 minus 3 over 2, then x squared. So y will be equal to, what's my x? It's 0. So 0 raised to the power 3 minus 3 over 2, then 0 raised to the power 2. Definitely that will all give you 0. So it is 0, 0. It's like that is the origin. Then to find the other coordinate there, we are going to say when x is equal to 1. So I'm going to say now, when x is equal to 1, what is the value of y? Again, we replace the x raised to the power 3 minus 3 over 2 x squared. So it will be y is equal to 1 raised to the power 3 minus 3 over 2 times 1 raised to the power 2. So that will be just 1, and that will give us 3 over 2. So if you punch it on the calculator, 1 minus 3 over 2, it is going to give you negative 1 over 2. So therefore the coordinate when x is 1, y is negative 1 over 2. So these are the coordinates that they wanted us to have. So this one here and the other one there. So these are the coordinates. So that's the way you can work out that. Right, I hope we are together and you're following. Please, you can pause the video so that you can rewatch and rewatch. It's a way of helping you, assimilate the concept. Let's look at, 2a. It says find the coordinates. So again, it says find the coordinates of the points on the curve. Yeah, so they want us to find the coordinates on points on the curve. Y, 2x squared. No, that is 2x raised to the power 3 minus 3x squared minus 36x minus 3, where the gradient is what? 0. So they are telling us the gradient is 0. So what we are going to do, against the same concept as what I showed you, first of all, get to know dy over dx. That will give us, for this one, it will be this times that, 6x raised to the power 2, this times that will again give us 6x, and that will give us minus 36. Remember, that gives you just a 0, so you can ignore it. Now, since they are telling us to find the coordinate to the curve where the gradient is 0, it simply means when dy over dx is equal to 0. So we equate the whole of these to 0. So it will be 6x squared minus 6x minus 36 is equal to 0. We can reduce the expression by dividing throughout by 6. So therefore it will be x squared minus x minus 6 is equal to 0. So it has now reduced to this one. So now we can actually try to solve this one. Allow me just to create more space. Let's try to see if I can create more space there so that we can now solve this one. So x squared minus x minus 6 is equal to 0. You can easily factorize that by getting the product. So a is 1. Remember the coefficient of the one having a square. B is a -1. The coefficient of x and our c is a -6. So product, sum, and factor. Product there, 1 times -6 is -6, sum, -1. So what are those numbers when you multiply? They'll give you a -6. When you add, they'll simply give you a -1. Are you thinking of 3 and a 2? Definitely. So we can think of a -3 and a 2. Therefore, when you replace there x squared, we replace these and write them in terms of x. Remember, -3x, and that will be 2x. So that will be minus 3x plus 2x minus 6 is equal to 0. So we have retained that -6. So we have only replaced the middle term there. So we group them and we factorize. But I could have told you right away, if you are quick, you know these things, it would have been x plus 2, and the other factor would have been x minus 3 is equal to 0. But let's just go, we factorize. What is common there is x. There will remain with x minus 3. There positive comes out. What is common is a 2. When I divide 2, I'll remain with x minus 3 is equal to 0. Group what is outside, it will be x plus 2. And take one of the bracket because they are the same. X minus 3 is equal to 0. You can see what I told you. Equate each bracket to 0. So it simply means that x plus 2 is equal to 0, or x minus 3 is equal to 0. So x is equal to -2, or x is equal to 3. So now you are going to use these values that you have found to replace in the original equation to know the value of y. That will give you the coordinates. So let's quickly do that. So we know it is -2 and that. So I'm going to say in this case, I'm going to say, when x is -2, what would be y? So you can replace into that one, 2x to the power 3 minus 3, x squared minus 36, x minus